Hello friends and welcome to another lecture on Cape Open Flowsheet environment. This is a problem that we are solving on simulation of ethyl benzene process. Now this is the seventh lecture in the series. In the sixth lecture we simulated the distillation column, and in the seventh lecture I will teach you how to hook up the recycle loop. As we are aware that the top of the distillation column, the benzene distillation column, is recycled back into the process. So how do we do it? Now, one of the fundamental mistakes that people do in a hurry, of course, is they take stream number 18 and connect it back here. That's wrong. You need to understand here that the reactor is working at a pressure of 20 atmospheres. And stream number 18 is coming out at 0.3 atmospheres. A stream which is at a lower pressure cannot enter a reactor which is at high pressure. Now, this is one of the fundamental errors that people do while hooking up the recycle. They do not take care of the pressures. They do not understand that, okay, what should be the pressure at which it should be sent back into the recycle loop. So the first thing that we need to do is, of course, understand this. And the second thing we need to do is save our flow sheet and then, of course, make a copy of it. So save as, and after save as, we save it as flowsheet 1.1. Now, why is this done? Now, normally what happens is whenever you try to solve for recycle loops, there are chances that the simulation might just crash. In that case, you will lose all your work. So it is better to make a fresh copy of your simulation by copying it and then doing the simulation in the copy. So in case the simulation crashes for any reason, you still have the copy of your work, the last copy of your work, which was complete. Now, the first thing that we need to do is take stream number 18 and put it in a pump so that we can increase its pressure or raise its pressure to 20 atmosphere and then put it back into the recycled benzene stream. So take this and take a pump, attach a pump here and take stream number 18, put it back into this pump, attach it into the pump and draw the outlet of the pump. So attach a stream to the discharge of the pump. Now double click on the pump, go on edit, select outlet pressure, and then afterwards come here. This is where we can set the outlet pressure and write 20 or type in 20. Close it and run the simulation. Now the simulation is done. It did take a bit of time. Now, as we can see in stream number 20, we have a very infinitesimal amount of ethylene flowing. But remember one thing, we started off with a recycled benzene loop in which there was no ethylene. And we can only hook up these two streams if the ethylene is 0. Otherwise, what is going to happen? This residual ethylene is going to keep increasing in each and every calculation and disturb the simulation and not allow it to converge. Why is this? This is not something dictated by mathematics. You also need to understand here that when ethylene is a limiting reactant, okay, then ethylene should get fully converted. That's very essential. It should get fully converted. It's understandable. You need to understand that every chemical engineer would appreciate that a limiting reactant usually converts completely. And if there is a recycle loop, if for any reason, there is some amount of reactant which is remaining. Now this will keep increasing in the recycle loop. Technically, otherwise also in real terms also this will happen. So for this, purging would be required. Now, how do we avoid this situation? What is the amount of ethylene that is unreacted? Let's check that first. So the unreacted amount of ethylene is 0.1302. So let's go back. Let's take this value. So it is 0.1302 divided by 3600 multiplied by 1000. I have converted this value in moles per second. So it is 0.03616 moles per second. Now what we can do is we can technically go and add this to the first reaction and ensure that ethylene is entirely used up. So in the first reaction, the extent of reaction is 152.5525. So we take this. So 152.5525 plus 0.03616. So the new value for extent of reaction for the first reaction in the first reactor is 152.5886. So that's 152.5886. Okay, so we are done with the correct values. And let's resimulate this now. And what do we get now? In stream number 20, the amount of ethylene now is really very low. And now what we have to do is, the stream number 2 that we have is at 319 Kelvin and it is at 20 atmospheres. Now we can take this stream and remove it and take the recycle stream and put it on the pump discharge. Afterwards, let's go to flow sheet and go on configure. And in configure, go to flow sheet options, and in relative tolerance, start with the least relative tolerance, that is e raised to -1, and start the simulation. The simulation has converged, and now let's see. As we can see that there is a very little amount of ethylene flowing into the recycle loop, and the amount of benzene flowing is 963.81. Now what we can do is we can rerun it once again to check whether the convergence is done. Okay, it has converged quickly and the values have not changed. Now what we can do is we can improve the tolerance. So we can go to flow sheet, go to configure and increase the tolerance. Now let's again perform the simulation. So this will take more time because now the tolerances have been increased. So it has converged. Now let us have a look on what are the values. Now we have 953 and 0.001. So the mole fraction of ethylene is really very less. Okay. So this could be one of the results that we can take. And the top temperature is 318.406, which is fairly close to what has been found in the flow sheet also. And the amount of ethyl benzene is 0.001. So let's check what do we have. The amount of ethyl benzene is 0.0005. That's half of it. And the ethylene is really very less. Okay. So if you want to further simulate it and get it to the values that has been published off, you can take 970. Okay. In the recycle stream. And then again run the simulation. hopefully it should converge to the value given. So let's check. So that's 969.4040612, and we are done. We are where the simulation work is. So this was 0.9989 into 969.4, and if you multiply it, you roughly come to the same value. You can always adjust this value and resimulate it till you get it to the article. But remember one thing, that these values do not make much of a difference. Okay, so the top temperature still is 318. So we are 1 Kelvin off, or 1 degree off from what has been reported in the article. Otherwise, practically for all other flows, we are very close. So this is my best result that I have got. And this, of course, meets the results of the article also. So that was all about how do we configure the recycle stream. And hope you have learned how to converge recycle streams by tinkering with the settings in the simulation. Now all the simulators have the settings that I have used, and the only setting that needs to be really tinkered along is with the recycle tolerance. This will give you faster convergence. Now, depending on what you keep, it will give you a faster or a slower convergence. It may give you a correct or a wrong convergence, and I have demonstrated how it works. So that will be all, guys. The only thing that needs to be done is putting another separator and hooking up the recycle. I will do this in the forthcoming lecture, and that will be the last lecture, and that will be the simulation of the entire plant. Do watch and subscribe my channel. I'm sure, I'm not hoping, I'm sure that you have really learned something about simulation today. Your knowledge from the first lesson to the 7th lesson has really given you a grip, a good understanding about what is process simulation and how do you use process simulators. So that will be all, friends. Have a great day. Goodbye.